Hi, in this video we will introduce the notion of Riemann sum and definite integral. This video is more theory and introduction of the notion. Later we will find tools and how to compute the values of definite integrals. Throughout this video we are assuming that f is a function defined on an interval a, b. So here this we are not assuming function is continuous. We are not assuming that it is positive. So here, as we did in the case of the area problem, we divide the interval AB into equal subintervals, n equal subintervals, x1, x2, x3, and so on. So the length of each one of these guys is going to be b minus a over n. And then we come and sample point from each one of these subintervals. So sample point xi star from the interval xi minus y, 1 and xi. So you pick a point. Then we form the sum that we find the value of xi, value of f at xi star, and then multiply it to delta x. Then add these guys from 1 to n. This is called the Riemann sum of f on the interval AB, while with the sample points xi stars. Well, as you can see, if I change the value, the sample points, we will get different values for this Riemann sum. And we need to note that when f is positive and continuous, on interval AB, and we choose xi star, the sample point, to be the end point, the right end point, then we remember we formed this Rn, and this is actually a Riemann sum for those specific cases, yes. And if we choose the sample point to be the left end point, we call that Riemann sum another Riemann sum, this, yes, that Ln. Basically what I'm trying to say is that the area problem was a special case of what we are doing here. Why special case? Because in the area problem, we only considered positive and continuous functions. While here, we are not assuming the function is continuous, nor we are assuming it is positive. So that's one thing that we have to keep in mind. The second thing is that, well, for different values of xi's, the Riemann sum will give you different values. So the Riemann sum, the value of the Riemann sum, depends on the choice of sample points. So it's not going to give you one specific value, but if you find the limit of this guy, so this is where then new definition comes in. So if the limit of the Riemann sums as the number of the subinterval increases exists, and no matter what we choose as sample point, we get the same values, and gives us the same value for all possible choice of sample points. So you divide it and then choose any sample points and then form Riemann sum and then let n go to infinity. Then we say that in that case, so the limit exists, and for all sample points of what give you the same number, then we say that f is integrable on AB, and the value of the limit, so what was the limit? Limit of the Riemann sum, I going from 1 to n as n goes to infinity, and this value and the value of the limit has a notation, is denoted by this notation. See, we have the function f of x. We write dx, same variable here, go from a to b. This guy is the notation for, is the definite integral of f on the interval sub a to b. When the limit exists for all values, for all choice of sample points, it and gives you the same value, so pick that value, and that is the definite integral we are looking for. Well, in this notation, you have to know a little bit more details about this notation. We have, first of all, two limits. This guy is called lower limit. This guy is called upper limit of the integral. And then d of a variable, in this case we put x, you could have put t or whatever you like, and the same variable would appear here. These guys, this variable x is called integrating variable. And the function that you put inside the integral is going to be called integrand. And well, first you have to make sure that a function is integrable. Then the second thing is that what is the value of that integral? This is the whole thing that we are going to learn throughout this chapter. Okay, so this was just introduction to what is definite integral, and then we will learn about the properties, the relation it has with the sum, and with the area and all other things.